So let's just wait maybe 1 to 2 minutes for the others. So I'm not sure if we are still 9 before our meeting ends in part 1. So may nakakaalam ba sa inyo kung ilan tayo kanina? Naging 10 ba tayo or 11?
Sir, 9 lang ata tayo kanina.
9 lang. Okay, so kung 9 lang, so nandito na kayo lahat. Anyway, so are you guys ready now to continue our discussion?
Yes, sir.
Alright, so again, if you guys have a question, so feel free to ask me anytime. Alright, so I think this is where we have stopped right here. So of course, converters can change AC to DC and vice versa. So if we have AC to DC, we also have DC to AC. So in some cases, we need AC. Okay, so that is why we have to convert. Let's say kung ang available lang is DC, so we have to convert that one into AC. But mostly, given na kasi laging AC eh. Kaya mostly no need to convert an AC anymore since it's the raw. Okay, yan yung fresh or natural power natin. So it's a AC or sine wave talaga. So mostly ang conversion na ginagawa lang natin is AC to DC only. Alright? Okay, so the next one here is Ohm's law. Sorry. Muna ako water. Alright, Ohm's law. So I hope you guys have heard this one already. So Ohm's law is what we call the relationship between current, voltage, and then resistance. Or in other words, ito yung parang nagbigay sa atin ng theory or idea how are they related with each other. Okay? So we call that one Ohm's law. So again, as usual, so uh, very familiar na kayo sa mga ganitong setup. Itong Ohms na to is mostly a last name of someone's who invented that law or that theorem or that theory. Okay? So this one is discovered by or was discovered by George Simon Ohm. Okay, so it is published in his 1827 paper. So title is the galvanic circuit investigated mathematically. So nagkumpisa tong Ohm's law na to, itong relationship ng current, voltage, and then resistance way back 1827. Okay, so napakaraming taon na. Actually, 194 years. So matagal-tagal na rin siya, itong Ohm's law na to. Anyway, so what is this Ohm's law? Ohm's law states that the current through a conductor between 2 points is directly proportional to the voltage across the 2 points. Okay, so introducing the constant of proportionality, the resistance. So when we say proportional, so meaning we have the current and then the voltage, which is proportional with each other. So once the current goes up, our voltage will go up also. So parang ganun. Kung tataas din yung voltage natin, vice versa. Kapag tataas yung voltage, tataas din yung current. So sila yung laging magkasama. Okay? However, kapag tumaas yung resistance natin, okay, so ito yung parang limiter natin. Okay, so let's say sumobra ka na sa current, sumobra ka na sa voltage. Ito yung pwedeng gawin ng tao. Okay, let's say pwede niyang taasan yung resistance into that certain appliances para malimitahan yung current or voltage na dumadaloy dun sa mismong appliance or device natin. Okay? So once arrived at the usual mathematical equation that describes this relationship, which is I is equal to V divided by R. So actually, the easiest representation of this one is VR. Okay. So laging ganyan yung actually ito yung pinaka-tinatandaan ko. Okay, and then the rest will just follow. So as long as you know this formula, V is equal to I times R, then you already good to go when it comes to Ohm's law. So from here, of course, you can derive this one into I is equal to V divided by R. So you can also have R. So R is equal to V divided by I. Okay, so yun yung mga ways for you to be able to solve the voltage, the resistance, and then the current. Alright, so of course, I stands for the current, and then V stands for the voltage, and then R stands for the resistance. So for the voltage and resistance, so very straightforward. Kung ano yung pinaka-first letter natin, that's also the abbreviation in Ohm's law. But in current, it's not C, because if you're going to put here C, kasi sa, actually hindi na siya sakop ng Ohm's law eh. Pag yung C kasi, under na siya ng capacitor. Okay? So sa current, it's represented by I. Alright? So I hope we are clear with this one. So any questions so far regarding the formula of Ohm's law?
None, sir.
Tabi ko na nga lang to dito para may notepad tayo. I pin. Alright. So tabi ko na lang din dito. Alright, so there you go. So Ohm's law, so nasabi ko na, discuss na natin to, nasasabi ko lang. So I stands for current, and then V is voltage, R is resistance. And then for their units, so I or current is in ampere, and then V or voltage is in volts, and then R or resistance is in ohms. Okay? So sa ampere, pwedeng A lang. For volts, pwedeng B lang. Okay? For ohms, hindi pwedeng O. Okay? So pag sa R, yung ohms natin, okay, itong ohms na to, is represented by omega. Omega ba to? Alpha. Omega, I guess. From the word
Omega,
ohms.
sir.
Okay? So, yun yung mga simpleng bagay lang naman na gusto kong malaman nyo, okay? So, A is short for A. I mean, ampere is short for A. And so, dapat capital hindi pwedeng small letter A. Okay? So, this is incorrect. Dapat capital letter A for ampere. And then V for volts. And then for ohms, this one is in omega. Okay? So, yeah, yun lang naman yung mga simpleng bagay na I want you guys to remember. So, types of circuit. So, alam nyo na to. We have series and a parallel circuit. So, for the series, we call it one series because the current is passing to one path only or one complete path only. Okay? So, meron tayo ng source, meron tayo ng path, another path, and then going back to our ground or negative source. Okay. Actually, combination of, pag sinabi kasi nating source, it's always a combination of positive and negative. So, laging ganun, laging babalik yan. Hahanap yan ng way para makabalik dito. Kasi kapag naputol dito, okay, so hindi na siya electric circuit mismo. So, dapat makakabalik yung electric natin or electrons natin mismo dito sa pinanggalingan niya. Okay? So, yeah, that's it for this series. So, I guess super dali lang neto. Wala na kayong problema dyan as long as merong single path, that's already a series. However, in here, we call this one parallel. Okay, let's get this one. So, we call this one parallel. That's because our current doesn't flow in one path or one complete path only. Ayaw. Ayan. Masyado yata maliit. And lakin ko. So if you guys are going to take a look on this one, so starting from here, we have here the total current, or we call that one IT. But upon reaching this node, okay, meron ng path dito, may path din dito, may path din dito. So in that case, kapag nahati yung current natin, okay, so ito yung pinaka key point nyo kung paano ba siya malaman kung parallel na ba or hindi. Okay, So kapag nahati na yung current natin, meron na dito, meron na dyan, meron na dyan. This one is already a parallel circuit. Okay? So this IT now is equal to I1. Let's say this is your I1, I2, and then I3. So your I total is composed of 3 individual currents. So of course, hindi yan magkakaparehas kasi depende kung ano yung value ng R1, ano yung value ng R2, ano yung value ng R3. Okay? So we have another rule in world of electricity. So yung electricity kasi na to, oops, okay, itong electricity na to, naghahanap to lagi ng path. Para din niyang tubig. Okay? So maghahanap siya kung saan yung mababa, kung parang saan siya pwedeng dumaloy. Okay, ganon din yung electricity. So naghahanap siya ng kung saan yung pinaka-less na resistance. Okay? The lesser the resistance, the more chance that that electricity will flow in that path. So the higher the resistance, so of course, the lesser the chance that it will flow in there. So in here, kapag mataas yung resistance, of course, mas mababa yung output current mo. Okay? Mas mababa yung resistance, of course, mas mataas yung output current mo. Okay, so ganun lang naman yung logic when it comes to solving currents. So, are we clear so far?
Yes,
Hello?
sir.
So again, for
Yes,
you to be
sir.
able to see that this one is parallel, okay, very good, is kapag nahati na mismo yung flow of currents natin. Unlike in series, okay, so never siyang nahati. From the start up to the end, buo pa rin yung current natin. Kung anong dumadali dito, ganun pa rin nung pagbalik. Unlike here, so, well, same pa rin naman. Babalik at babalik pa rin naman lahat ng currents natin, pero nahati siya at some point. Okay, so dito, pag na-reach na nila yung I1, I2, and I3, so of course, I total na ulit to. Okay, yan. I total na ulit siya. Starting from here, I total, starting, and then going back here is I total. So, laging babalik yan sa main source natin. Right? Okay, so we also have combination circuit. So, when we see combination, so very obvious naman, meron tayong series parallel wherein it has a series connection and a parallel connection at the same time. Okay? So, in here, so note that the hyphenated term series parallel uses the word series first, so nauna yung series, to emphasize the major circuit, and the word parallel second to indicate the minor connections. So meaning kapag sinabi nating series parallel, mas maraming series connection kaysa sa parallel. Though they are a combination. Okay? And of course, vice versa. So this is an example of series parallel. And then vice versa. So parallel series. So again, parallel is the major circuit. Okay, and then series is the minor connection. All right. But to make it simple, kasi if you guys are going to take a look on this one, okay, this one has a series connection right here, series connection right here, and then if you combine these three, this one now is one series connection. So, lagi na lang ganito. Okay, kapag nahati, okay, or kahit merong isang path or connection na naging parallel, that's already a parallel connection. Okay? So, never mind the word series parallel and then parallel series. So it's just a term to say that there's more parallel, there's more series in this connection. But in reality, parallel lang siya. So nahati lang tayo sa dalawa. Okay? It's either series and then parallel. So for series, isa lang yan. Ganyan lang yan, isang flow of current lang. For the parallel, madaming types of circuit dito. So pwedeng ganyan. Okay, so parallel yung tatlong resistor na yan sa voltage source na to. Meron pang ganito. Okay, so may resistor pa dyan. Tapos mahati pa dito, may resistor na naman. Tapos dito may resistor na naman. Okay, so this is already a parallel. So hindi mo na kailangang intindihan series parallel ba to, parallel series. Okay, so na-mention ko lang dito kasi para malaman nyo kung bakit may series parallel and then bakit merong parallel series. So just to let you know that whichever comes first is the major connection of circuit, okay, on that circuit or sketch, ang tawag dito, schematic. Okay, so this is a example of parallel series circuit. Okay, so no, don't mind that one. So again, I already made it simple. So series, ito lang siya. And then parallel, napakarami niyan. Maraming mga representation ng parallel series. Parallel series. Parallel circuit. Okay? So we have here an example. Try ko nga. Yan. Pwede pa palang mukha niyan. Nagilid ko lang to. So we have here an example. So a 30 ohm resistor is connected in series with a resistor R whose ohmic value is unknown. So if the current is 2 ohm, when the circuit EMF is 115 volts, calculate resistance of the unknown. So in here, the first thing that you need to do is, draw the schematic diagram. So dito, ang papansinin nyo, series naman siya. So wala tayong problema. Napakadali lang niyang i-drawing. So again, kapag sinabi nating series, mostly ganyan lang naman yan. Isang path lang yan. Okay? So nandito yung voltage source natin. So the longer one represents the positive and then the shorter one represents the negative. And then we have here EMF. So mostly, when we say EMF, okay, this one is equal to voltage. Okay, or sometimes it's being represented by big letter E. So all those three are just the same. Okay, para-paras lang yan. So EMF is yung voltage source natin, V is voltage, or sometimes VS pa nga to eh. Okay, VS stands for voltage source, and then E stands for electricity or electric efficiency, okay, or electromotive force for EMF. So marami siyang mga terminologies but all of those are just the same. Okay? So I hope hindi kayo malito kapag sinabing EMF. Bakit EMF? Bakit hindi lang a voltage source? Okay? Mga ganong bagay, kumbaga. Alright, so from here we have an EMF which is equal to 115 volts. And it says here that a 30 ohm resistor is connected in series. Oops. So meron tayong resistor dito which is in series. So this one is 30 ohm. And then with a resistor R whose ohmic value is unknown. So we have another resistor in here in which we don't know the value. Okay? So in here, we can just call this one as your R1. So this is just a label. Okay, para mas mapadali kung saan ba yung R1, saan ba yung R2, R3, etc. etc. And then let's say this one is your R2. Masyado yata makapal to. Or masyado lang naka-zoom. Anyway, yan. Okay, so the question here is calculate the resistance of the unknown. Okay, so never mind this one for now. So papakita ko na lang sa inyo muna step by step kung paano natin nakuha yan, yung 27.5 ohms. So again, going back to our formula, we have V is equal to IR, right? So from here, we can derive R is equal to V divided by I. So we can already use this formula to solve for the R total. Okay? So R total. So once you are solving for the R total, you must also get in the V total divided by the I total. Okay? So just to give you an idea why do have RT, VT, and IT. So kapag kinuha nyo yung RT, dapat total din lahat yung mga values nyo. Kapag kinuha nyo lang yung specific resistance, okay, dapat specific voltage and specific current lang din yung gagamitin nyo. Okay, so magkaiba itong dalawang to. Alright? Pero for now, medyo complicated pa tong R2, B2I2. So, hindi muna natin to gagamitin. So, let's focus with this formula for now. RT is equal to VT divided by IT. Since VT is already given and then IT is also already given. So, if the current is 2 amp, so, lagyan na lang natin dito, IT is equal to 2 amp. So, from here, RT is equal to 115 volts divided by 2 amps. So, RT is equal to 57.5 ohms. Palakihin natin para may space pa tayo. There you go. Okay? So, ito na yung R2 natin. So, hindi pa natin nasasolve yung R2. Okay? So, again, in series, for you to be able to get the R total, just get all the summation of your resistors in that circuit. So, we can derive this one summation kung ilan man yung RT natin. So, we have R1 plus R2. So, kung ilan yung resistor nyo dyan, i-add nyo lang lahat para makuha nyo yung R total. But in here, since we already have the R total, which is the 57.5, okay, and then we already have the R1, which is 30, right here, 30 ohm resistor, plus R2. So, nag-iisa na lang yung unknown variable natin. So, from here, we can already solve for the R2. So, R2 is equal to 57.5 minus 30. Alright? So, R2 is equal to 27.5. So, that's how we've got ohms. That's how we've got this answer right here. Okay? So, were you guys able to follow?
Yes, sir.
Yes, sir.
Alright, so very good. So, question so far? Yung mga katanungan ba? So, we are now 10. Okay, may nadagdag na isa. Okay, that's good. So, no question?
None, sir.
Alright. Okay, so, madali pa lang naman siya. Alright, so for the number 2, a 3-ohm resistance is connected in parallel with a resistor R whose ohmic value is unknown. Okay, so same pa rin yung resistance natin, let's say your R1, but it is now in connection of parallel. So from here, so we can, so sometimes, yung mga symbols natin sa circuit ng voltage source, so mostly ganito, positive and negative. So parehas lang yan, dinagdagan lang. Parehas din yan, dinagdagan lang din. So kahit dalawa lang yan actually, positive and negative, as long as there is an indicator where is the positive and then where is the negative. So this one is the same with a circle, wherein sometimes we have positive here and the negative. Alright? So, ano pa ba? Actually, meron pang isa, pero dependent na kasi ito dependent voltage. So sometimes it's also triangle, wherein we have positive, negative. But if it's a triangle, this one now is a dependent source. Meaning, nag-depend na to dito sa mga, let's say, yung current na dumadaloy dito, yung resistance na nandito. Okay, so hindi lang siya fixed na voltage. So we call this one dependent voltage, and then the other two is independent voltage source. All right. So later on we'll discuss more on that one. But for now, let's answer number 2. So we have here a parallel connection. So let's use a circle, positive, negative, and then this one has a EMF of 114 volts. So EMF is equal to 114 volts. So they are now in parallel. So this is your first resistor, R1, which is 30 ohm. And the other one is an unknown. Okay, so let's call this one R2. So R is equal to question mark since we don't know the value. So if the total current taken by both resistors is 5.7 amp, so right here we have an I total of 5.7 amps. So upon reaching this node, okay, so magi-split na yung current natin. Okay, so some currents will go here, some currents will also go here. So in that case, we have a parallel connection. Okay, so in the circuit, EMF 1.0 volts, calculate the resistance of the anode. So same question, we have to find the value of this resistor, which is unknown. So the quickest way is get the individual current. Okay, so you have to know, let's say this one is your I1 and this one is your I2. Because from here we can derive a formula wherein we have IT is equal to I1 plus I2. So IT is already given, which is 5.7 amps. And then I1 is solvable. Okay, so how do we solve for the I1? I1 is equal to V1 divided by R1. Okay, so this is another thing that you guys need to take note. So in a parallel connection, so I hope you guys have already, oops, ano nangyari? Yan. Parallel. Okay, in a parallel connection, your total voltage is equal to, let's say, your V1 is equal to V2 is equal to V3. Okay, kahit ilan pa yan. Okay, so the V1 is represented by the first node right here, and then V2 is second node, and then V3 for third node, etc. etc. kung gaano man siya karami. Okay, so ganon sa parallel. So makikita nyo to sa rule nung second module natin, sa module number 2, na VT is equal to your individual voltages. So from here, V1 is equal to VT. So your VT or total voltage is 114. And then R1 is 30 ohms. So 114 divided by 30. So gamitin nyo lang din yung calculator nyo to solve for this one. So we've got a value of 3.8 amps. Alright. So from here, we have this formula, IT is equal to I1 plus I2. So IT is 5.7 is equal to I1, which is 3.8, okay, plus I2. So from here, we can already solve for the I2. So I2 is equal to 5.7 minus 3.8. Okay, so I2 is equal to 5.7 minus 3.8. This one is 1.9. Oops. 1.9 ampere. So from there, we already know the value of I2, so we can already solve the value of R2. Okay? Because, again, from B is equal to IR, we have R is equal to V divided by I. And since we are solving for the specific resistance, which is the R2, so we have to get the V2 and then the I2. So again, V2 is equal to your total voltage, which is 114 volts, divided by I2, which is 1.9 ampere. Okay. So R2 is equal to 60 ohms. Okay? Pasensya na kung medyo slanting siya. Pero doon napupunta yung kamay ko eh. Hindi ko alam kung bakit. Anyway, this one is 60 ohms. The same with this one. Alright? So, are we clear so far? And how did we get 60 ohms for this unknown R2?
Yes, sir.
Yes, sir.
Okay. How about the others?
Yes, sir. Okay lang.
Alright. So, if you guys have a question, so again, feel free to ask me anytime. Okay. So, number 3, we have here a series circuit like that's shown in figure 3.3a. So, 3.3a is this one. Okay. Oops. Has a 24 volt. So, check ko nga lang. Binigay ko bang exercise to? Exercise number 1, number 3. Exercise number 1. Kala nga, hanapin ko yung I guess binigay ko to as your exercise. Check ko nga. Para makasigurado tayo. Preview. 3 point... Hindi. Iba. 3.3a. Okay, so iba. So let's answer this one, number 3. So a series circuit like that shown in figure 3.3a has a 24 volt battery that delivers a current of 1.5 ohm. So if R1 is 3.4 ohms and R3 is 6.2 ohms, calculate the ohmic value of R2. So let me just copy this one for us to have a quicker way of doing this one. So meron tayo na ito. So E is equal to So your voltage source, bakit yan? So your voltage source is equal to 24 volt. Okay. And R1 is 3.4. 3.4 ohms. R2 is... Ano bang R2? R3 is 6 point... ba yun? Ba't parang kulang? 3.3A. Is this 3.3A? I see. So my bad. This is not 3.3A. The 3.3A is right here. Okay, figure 3.3A. So kunin natin to. Kaya pala bakit walang R4, R5, R6? Okay. So we have a 24 volt. 24 volt of battery and then a current. So I total is equal to 1.5 amps. And then R1 is 3.4 ohms. Oops. And then R2 is unknown, I guess, and R3 is 6.2 ohms. Alright, so it says here calculate the ohmic value of R2 since that is the only one that is unknown. So again, from here we can do this by having this formula. RT is equal to the summation of R or equals to R1 plus R2 plus R3. Okay, so we don't know the value of RT yet. So let's solve for the value of RT. RT is equal to VT divided by IT. So VT is 24 volts, and then IT is 1.5 amps. Okay, so from there we can already solve for the value of RT. So 24 divided by 1.5 is equal to 16 ohms. Okay, so RT is 16 ohms. R1 is 3.4 plus R2. So R2 ito. Plus R3 is 6.2 ohms. So from there, we can already solve for the value of R2. R2 is equal to 16 minus 3.4 minus 6.2. So R2 is equal to 3.4 minus 6.2 minus. So you've got an answer of 6.4 ohms. Okay. Did you guys get the same result? Or may nagtry ba sa inyo? Hello? Are you guys able to follow?
Yes, sir.
How about the others?
Yes, sir.
All right. So what we did is we've just derived the solution from this 1 RT is equal to summation of resistance. And then from there, we get the value of RT and then put it in here. And then just put the uh, equivalent values of your resistors. And then from there, you can now solve the value of R2, which is 6.4 ohms. All right, so since we don't have enough time again anymore, so we'll just continue the rest on part 3. Okay, so goodbye for now and see you guys later on part 3.